Okay, good morning, everyone, and welcome to our joint webinar of the COBALT and CYberSynchrony projects titled Roadmap to a European Trusted Cyber Ecosystem, Tools, Policies, and Certifications. Please note that the session is being recorded and the full recording will be uploaded to the both projects' YouTube channel. Today's webinar will focus on cybersecurity tools, cybersecurity certification, policy developments, and how emerging solutions such as automated compliance tools and modular cybersecurity frameworks can support organizations in practice. We have a full agenda with excellent speakers, and we will conclude with an interactive Q&A and discussion on policy recommendations. Before we begin, just a quick note, please feel free to post your questions in the chat in the Q&A throughout the session, and we will address them during the final discussion. So let's get started. To begin, I'm pleased to introduce the COBALT project and give the floor to Ioannis Koufos from Demokritos as coordinator of the project, who will walk us through the vision and the objectives of the project. Ioannis.
Hello, Lenny. Hello, everyone. Thank you very much. I will introduce you COBALT. COBALT is a European project focusing on cybersecurity certification, this is a consortium. We bring together 14 organizations spanning across 7 European countries. Most partners are located in Spain, France, Germany, and Greece, and Cyprus as well. Next slide, please, Eleni. So, which our motivation? It's actually the fragmented cybersecurity landscape. And what we mean with that is that it happens that there are many diverse ICT domains, such as cloud, IoT, AI, industrial, and quantum as a whole. Across these diverse domains, there are multiple standards that most often we cannot address them all at once, and they create inefficiencies when you try to address them in the same manner. And this leads to many consequences, such as high costs, redundant audits, and low interoperability when focusing on specific, let's say, sectors rather than and addressing specific standards rather than, let's say, taking another approach. And this is why we need a harmonized, scalable, real-time assurance model. Next slide, please, Eleni. So we have seen many, let's say, attempts through different, let's say, acts and frameworks to address the cybersecurity certification and compliance. First of all, we have the Cyber Resilience Act. Cyber Resilience Act focus on enhancing cybersecurity and cyber resilience in Europe, in EU, by providing common standards for products, and especially, it is important because it mandates manufacturers to address the product life cycle and manage the security that is being a part of the whole, let's say, process, and also establish certain requirements for both the manufacturers and the users as well. So, continuing, we have the Cybersecurity Act. The Cybersecurity Act helps us in creating a common framework for the cybersecurity certification for any ICT product, service, or process. Establishes monitoring compliance requirements with monitoring compliance with certification requirements. And make use of repository listing vulnerabilities as additional cybersecurity information for certified products. And it's also directly connected with EUCC and EUCS. On top of that, ENISA has focused on the network information security framework, NIS2 in particular, and this promotes the cooperation information exchange among EU members in order to prevent and respond to all kinds of different cybersecurity incidents. The NIS2 initiative also addresses supply chain security and establish relationships with high-risk third-party, let's say, services, service providers, vendors and partners to make them aware of the risks. So, which is the gap that COBALT tries to address? Current models regarding the certification sector are static and paper-heavy. We have a lot of manual documentation, we have lengthy audit procedures, and one-time compliance checks, especially in internal audits, and this makes it quite difficult to to consider constant changes and also address them efficiently. We have no continuous monitoring support. This means that traditional certification lack mechanisms to, let's say, that address real-time or periodic validation of compliance, and this leaves our system to be variable between audits, not capturing all the changes that take place in between. We have actually they're also inadequate for fast-evolving threats and complex systems. We can consider, for example, a very big organization, and when you try, let's say, to address this big organization as a simple environment with rapid changes, this does not reflect, especially, this does not actually is efficient and easy to handle when we have a constantly changing threat landscape and a heavily interconnected system. Static certifications fail to adapt, and as a result, we have many emerging risks coming from our configurations. There is also a lack. Sorry, Ellen, please back one slide back. Yeah, and also there is a lack of readiness for dynamic and modern ICT environments. The rapidly changing threat landscape not only address the complex systems, but also, as previously mentioned, but also does not allow us to easily cope with static certifications, especially when these fail to adapt to the previously mentioned emerging risks. Can you please continue, Eleni? Yeah. So what COBALT tries to bring in this area. COBALT has 5 distinct objectives. The first one is to build a unified information model for EU certification of ICT products, focusing on quantum computing and providing trusted sharing. COBALT offers a holistic cybersecurity repository that collects and provides tools, procedures, and practice in order to support the whole initiative, and also leverages the international data space primitives to fortify trust among different stakeholders and allow efficient data sharing. The second objective is that we take advantage of digital twin technologies and try to answer the question that if the digital twin of a system is certified, is the physical counterpart effectively certified as well? So apart from that, we try to develop secure digital threads for different purposes across the value chain, and this way we standardize digital twin and physical system symbiosis in a holistic manner. The third objective focused on addressing high-performance computing and AI certification through the scope of quantum computing. We assess and analyze existing procedures and processes in the Focus Quantum Computer Lab coming from our partners in Germany. The objective 4 is about demonstrating and showcasing the developed framework in a set of cutting-edge pilots. And these pilots, as you will see in the next slides, focusing on AI application for Industry 4.0, quantum use cases, and the regular ICT infrastructure. The final objective is about maximizing the impact of the COBALT results, and this way we try to foster the creation of an open source community around the COBALT solution, bringing together a lot of different stakeholders. Next slide, Eleni. So what is COBALT? COBALT attempts to unify, to wrap up essentially, the cybersecurity certification process across EU ICT industries by bringing together a common certification model which operates throughout the whole, let's say, life cycle of our vision. This is supported by our digital twinning technologies, decentralized processing, and trusted data exchange. COBALT brings together a lot of different, let's say, enablers, which we'll analyze next. And our use cases, as you can see, are inspired from, first of all, the Industry 4.0 use case is inspired from the real-world AI vision model that could, for example, detect manufacturing process anomalies and defects, and we try to address such, let's say, such AI use case when these are also applied on, let's say, critical infrastructure or let's say, important manufacturing business. And also, the second use case is about establishing, let's say, a quantum computing cybersecurity certification framework, and this achieved by utilizing quantum oracles and quantum algorithms. For example, the Grover Sales algorithm for structured database. And the digital twin in this case that we try to use is the Eclipse CRISP language developed from the Fraunhofer partners in Germany. So what are the COBALT innovations? First of all, we automate the whole certification process. We bring together a common information model and a language, precisely mentioned as CCM and CCL. And this way we foster continuous certification by leveraging, let's say, a machine-readable language to automate the certification process. We also bring on board the secure digital twin. This digital twin mirrors real time in real time and simulates IT systems, and particularly complex one in our case, and also is an enabler for evidence collection, synchronization, and simulation of the COBALT workflows. We also bring quantum oracles and AI certification, and this is achieved by using the CRISP language for programmable quantum computer applications, and we benchmark the usage of both the quantum oracles and the AI, let's say, use cases under the spec 9148 for quantum computing hardware and also for software certifications. We also use decentralized ledgers for trust and traceability in certification updates. Next slide, please, Lenny.
Thank you. Yeah. Thank you very much, Ioannis, for this clear introduction to COBALT and its objectives. As we heard, COBALT is working towards enabling more efficient and automated approaches to cybersecurity certification. We will now move on to CyberSynchrony project, which complements this vision by focusing on modular and flexible cybersecurity frameworks. It's my pleasure to invite Violeta Vasilieva from Angioli as project coordinator to introduce CyberSynchrony.
Thank you very much, Eleni, and hi everyone. So I'm very excited to share a little bit more about the CyberSynchrony project. First of all, the main challenge that the project is addressing is the fragmented cybersecurity capabilities across sectors and countries, including aspects like limited coordination, weak risk visibility, and insufficient adoption of advanced cybersecurity solutions across different domains. Next slide, please. So the main objective, as mentioned briefly, is a modular cybersecurity framework that connects people, processes, and technology to enable faster, coordinated, and more resilient cyber defense across EU member states, and at the same time also empowering SMEs with accessible tools, knowledge, and support to enhance their cybersecurity capabilities. So the support for SMEs is mainly happening through a financial support program where the project is providing funding up to 200,000 euros to SMEs across Europe via open calls in order to enable the development and deployment of innovative cybersecurity solutions in real-world environments via using and also enhancing the CyberSynchrony modular framework. Next slide, please. So to address all the challenges that I mentioned previously, the project has defined the objectives, which I will address very briefly. So the first one is the enhanced threat assessment and risk monitoring, the rapid and automated incident response, the strengthened continuous risk monitoring, cross-border cyber exercise and readiness, which is happening through different large-scale simulations for preparedness of different member states. Also secure and standardized communication, promote European-wide cooperation and knowledge sharing across the partner countries, also advanced threat intelligence and analytics, One main thing, of course, is to build cybersecurity culture and awareness, mainly through awareness campaigns, trainings, and gamification approaches to cybersecurity. And last but not least, to strengthen governance and compliance by providing a unified cybersecurity standards and resilience mechanisms for further policy recommendations. So the project is delivered by a consortium of 12 partners spanning across several different countries such as Italy, Cyprus, Netherlands, Greece, and Belgium. And it is representing a quite diverse aspect of professionals from SMEs, public sector, academia, industry. We also have a hospital involved and different training providers as well. So the approach is to build on each organization's strengths and focus on results, especially the technical delivery of the different cybersynchrony modules, and also user engagement in terms of SMEs and also participants and professionals from different domains that we are addressing. Also, CyberSynchrony offers a full suite of cybersecurity modules, each designed for very specific needs. And here we can see a very high-level overview of the modular framework that my colleagues from Janus will present a little bit later today. But basically, we have 6 different modules: CyberSQ, Cybeira, CrossCore, and CyberRide, each addressing different technical aspects related to cybersecurity, and 2 additional modules, CyberGo Plus and CyberWise, which are mainly focused on the governance compliance and also on the education for all. So the target mainly is the EU member state cybersecurity authorities and critical infrastructure operators, also cybersecurity professionals, SMEs, and researchers who adopt and extend the framework that is provided for the project. And the framework is designed mainly to enable third-party cybersecurity tools and applications, and also support external SMEs, spin-offs, and researchers. The project has duration of 36 months, is divided into 3 phases. We are currently in phase 2 of the project, and is covering 3 different use cases that are addressed very heavily into our activities. Next, so the 3 use cases we have are related to 3 verticals from the NIS2 industries. So basically, we have healthcare, we have public administration, and we also have education or academia. So the first use case is on digital healthcare. And mainly that use case is because the integration of technology in healthcare has driven major advances in medical devices and also AI, improving treatment and monitoring. However, it also increases vulnerability to cyber attacks, threatening patient safety and system integrity due to design flaws and weak securities. So since COVID-19 pandemic, cyber attacks on healthcare facilities have risen significantly, exposing gaps in current protection. So within this use case, we have 5 main objectives that we are aiming to achieve within the project and also the framework, but mainly to implement robust encryption methods and secure sensitive patient data, also conduct regular cybersecurity audits and risk assessment of healthcare IT systems, establish real-time monitoring systems for detecting unauthorized activities and also potential data breaches, develop and implement a comprehensive incident response plan for cybersecurity threats, and also, last but not least, to train healthcare staff in cybersecurity best practices and awareness. This use case is in collaboration also with the hospital, so we are really having a hands-on approach towards addressing the issues that come with digital health and services for patients. Next slide, please. So the public administration is also quite interesting use case because public administrations are critical for citizen services, making cybersecurity essential for trust, security, and governance. We know that a lot of cyber attacks are surging 600%, and 95% of the breaches is tied mainly to human error. So secure e-governance platforms are urgently needed as of now. And yet agencies face significant hurdles, for example, legacy systems lacking modern defenses, sensitive data obligations, budget constraints, of course, limited expertise, and poor cross-departmental coordination. So to address these challenges, we also have identified 5 objectives in line with the cybersynchrony framework, which are the following. First, to safeguard the integrity and security of online services offered to the public, to implement digital IDs for secure and efficient citizen identification, the use of also blockchain technology for tamper-proof public records, to develop and implement comprehensive incident response plans for cybersecurity threats, and again, last but not least, to train public administration staff in cybersecurity best practices, and also raising the cyber awareness and hygiene across the staff in those public administration departments. We are also collaborating with the municipality of Egaleu in Athens. So they're also using, we are using them as the main use case in order to test and validate all the concepts we are developing in cybersynchrony. Then the last use case is towards academia. We are working with the University of Piraeus, who are leading this use case. And the main challenge here is that universities must protect IP, most importantly, student data, and also ensure operational continuity while meeting data protection requirements. However, again, tight budgets, diverse user skills levels, complex IT ecosystems, and reliance on third-party platforms makes maintaining consistent cybersecurity standards a significant challenge also in this sector. So the 5 objectives here that we have identified to address these issues is to guarantee the integrity and safety of e-learning platforms utilized by the institution, put in place strong digital security measures to safeguard critical research data, ensure the confidentiality and integrity of student academic and personal records, equip teaching staff with the knowledge and skills needed for cybersecurity best practices, and also formulate and execute a detailed plan for handling cybersecurity incidents in such environment. So all these use cases are currently in place, and we are basically using the cybersynchrony different modules and tools that we will go over a little bit later in the presentation today to actually also showcase the technology behind addressing those objectives in order to address the challenges within those 3 sectors. So next slide, please. Yes, so this is from my side. Thank you very much for your attention. And I think later we will also have some time to address any questions or topics. Thank you.
Thank you very much, Violeta. We will now move to a broader perspective on certification schemes and policies. I'm pleased to invite Anjan Chatterjee, who will share insights on current cybersecurity certification schemes and the policy landscape.
Thank you so much. Thank you so much. So I'm Anjan Chatterjee. I'll just start with a brief introduction. I'm Anjan Chatterjee, working as data engineer at TUSUD here in the UK. I'm responsible for COBALT project as a project lead. And in COBALT, we are doing the dynamic risk assessment part. We are responsible for integration and also the standardization and dissemination activities in the COBALT project. Apart from that, I'm also responsible for cybersecurity initiatives across our organization and other digital business initiatives as business development. Okay, so saying that, I'll move to the first slide for this webinar. So the very first question I would like to put forward is like why we would consider putting forward cybersecurity certification in the first place. So for any organization, the first thing is we have to care for our assets, and by assets, it's digital asset. It's the people that we have to safeguard. We have to safeguard the security properties. We have to safeguard the safety functionalities of the organization. So the cybersecurity certification drivers would mandate all these requirements. If we talk about people, the safety increasingly depends on the correct operation of digital components. So if we talk about digital assets, it's not just a digital asset, it's also linked to some physical asset, and we can consider changing of digital control systems. We can change digital control system can change any safety requirements of some physical asset, and that could lead to some safety hazards. Which could be dangerous for people on site. So we have to think about safeguarding our digital assets, both physical assets and digital, and we have to safeguard our people at the organization. Saying that, we have to fulfill the sectoral demands. So each industry has their own specifics to create requirements for their cybersecurity certification. For example, healthcare have their own requirements, automotives different requirements, finance different requirements, so on and so forth. At the very end, we have the legislative requirements, which are the mandatory requirements. So once a legislation is in place, we have to meet those requirements that are put forward. And this is the last step, because legislation and mandatory putting forward any legislative demands comes at the very last step. So you can see it starts from voluntary, and then comes the semi-mandatory, that is the sectoral phase, where we might have voluntary or we might have mandatory requirements. And lastly, at the end, when we have to meet the legislative demands, we come to the mandatory phase. Next slide, please, Alini. Yes. So here we can see the certification landscape overview. The picture looks a bit complex, but I'll try to narrow it down. So you can see it's grouped into three main categories. One is for data protection, where we have GDPR and the Data Act. Other, we have the product safety requirements, where standards from IEC and so on would come into place. And other, we have the cybersecurity product requirements. So in the cybersecurity product requirements, I would say the most important part, which is coming forward and which will soon set the conformity assessment requirements for all products and digital elements, is the Cyber Resilience Act. So that's like the central part of this whole group, I would say. And the level of assessment required will vary, but any product placed on the European market, like if we're just talking about European market, will subject to the requirements of this particular legislation. Also the new cybersecurity law, which is being introduced, it has been introduced in a coordinated manner, and CRA will have an appropriate relationship with other regulations as well, such as the NIS2 and the AI Act. And the certification schemes are already being described and implemented in the CSA, the Cybersecurity Act, will also be used to assess compliance under CRA. And everything is linked to the products and associated services that we are talking about. Okay. So the next slide is for the regulatory drivers for certification. If we're talking about European legislation, cybersecurity we have ENISA, which is an established body responsible for creating the certification programs and the frameworks. We have EUCC, EUCS, EU5G, among which the only fully operational is the EUCC, so that's why it's marked in green. On the other hand, we also have other regulations like the AI Act and CRA, as I mentioned, and these also impose mandatory obligations to ensure that digital resilience of products throughout the life cycle is maintained. This in turn, it generates a new needs to create new security standards and reinforces the need to develop further certification programs. The next edition of CSA should include new requirements for the implementation of European certification programs, resulting to the entry from the entry phase into the force of new legislation. The CRA regulation would have 20 types of product, which are grouped into categories such as default, important, further being classified under class 1, class 2. And then we also have the critical class of products. Same for AI Act. We have the high-risk AI systems and low-risk AI systems. Next slide, please, Eleni. Okay, so if we talk about the main certification demands that all this legislations would put forward, first one is the life cycle support, which includes the design and development, the production, the market placing, the support period for the product, and also the decommissioning of the product. Next is the continuous monitoring, where we have vulnerability handling, the lifecycle risk management, and the regular updates for the product. And third is surveillance, that is the automation of surveillance and coverage of multiple schemes that we might consider for the product, the reporting obligations that we might have, and the updated information or dissemination of storage of information. So these are the main certification demands that any of these legislations that I talked about would put forward. And as a response in COBALT, we are responding to these requirements. So in COBALT, we have a dynamic risk assessment, which fulfills the demand of lifecycle risk assessment, the vulnerability management, the scheme definition, the surveillance. In COBALT, we also have the dynamic conformity assessment, which is fulfilling the demand of vulnerability monitoring, the lifecycle security of the product, regular update support. We have CCM ledgers, which is also meeting the demands of surveillance support and continuous reporting obligations. And we have evidence collectors, where we are managing compliance by surveillance, supporting surveillance, collecting the evidences and keeping them secure through the ledger. Next slide, please, Eleni. So now I would like to bring forward the standardization activities that we have already performed in COBALT. So we have contributed to the ISO 27090 on AI cybersecurity. We have also reviewed the NISA UCS certification scheme. We have contributed to CyberStand for the development of standards based on CRA. We are actively participating in the Cyber Resilience Act working group. That's JTC 13 working group 9 of Sense&Lec. And we are specifically contributing to the security vulnerability handling. That is part of project team 3. We are also participating in JTC 1 of ISO, which is on security evaluation, testing, and specification requirements. That's working group 3. Very recently, we are also doing the liaison organization status with the JTC 21 working group 5. That's the AI working group. And we are doing this together with the European Cybersecurity Organization. So that's all from my side. Thank you so much for your attention. I would like to move forward to our next presenter.
Thank you. Thank you very much, Anjan, for these valuable insights. This overview highlights both the progress made and the challenges that remain in cybersecurity certification, particularly from the policy and implementation perspective. So thank you very much for sharing. We'll now move on into a more technical, let's say, contribution. I will give the floor to Prof. Antonio Scormetta to present COBALT's approach to automated compliance, including the use of OSCAL-based tools.
Okay, Eleni, many thanks. Can you hear me?
Yes, we can.
Yes, can hear you.
Yes.
Okay. Sorry, because the camera, I don't know, it's not working now. I mean, I have tried to change it, but okay. Sorry about that. As already presented by colleagues, as you can see here, there are several challenges that are now appearing because of the requirement coming from all the different legislation, coming from NIS2, from CSA, from CRA. All of them at the end are identifying the needs first to address the complete supply chain of the security. So not just consider, I would say, one phase in that sense. How to manage basically all the mechanisms and all the solutions that at the end support the idea of a common framework for the certification, cybersecurity certification in that sense. How to integrate on this process the issue of the different mechanisms, basically, and list of solutions that already been provided by a system. At the end, a system is composed of subsystems, and many of them already have certain restrictions, certain requirements, certain security aspects that need to be also taken into account. And at the end, the important thing is that all of this is affecting that we need to be aware of the different kind of certification standards that need to be taken into account, how they are related to each other, how all this affect during the life cycle, I would say, of the system, going from the design up to operational model, and how all this information need to be in some sense ensembled in a way that the tools that need to be provided to the end users, in the sense, could facilitate the management of this amount of information and different documents that need to be used in that sense. So if you go to the next. Taking that into context, obviously, as I said, there are several challenges. Some of them already have been indicated by my colleague. One of them is clearly that up to now, most of this effort in the certification process and in the verification of the security capabilities of the system are being done in some way manually or through tools, but basically that they are decoupled one to the other. So in order to maintain basically the consistency of the whole system, there's a great of effort, a cost of time, time and cost, basically at the end of the same thing. The other important thing is that in most of the case, we are duplicating some of the processes because some parts are being taken by some unit, other one are taken by other. But it is important to try to reuse as much as we can the information that is already being generated, specifically if we're talking about the evidence that later are needed in order to assess the complete picture of the security capabilities of a system, of a product in general. So we need to need mechanisms to facilitate the integration of all this information that is needed in order to do the composition, basically, of the security, and specifically when we're talking about the life cycle of the system. And the other important aspect, as already was mentioned by my colleague, is that all this process is not static. It's not happening once. It's something that is happening continuously. You can do certification of a product, but later new vulnerability appear. We need to create mechanisms that to take into account that issue, how this affect the existing certification process, how to dynamically recertificate the product based on this new vulnerability, and how we need to keep track of this. Already have been mentioned by Anjan, for example, they need to do some kind of monitoring and traceability of all this process over the whole process. And at the end, and just an important aspect is that, as I already said, the important thing is also how to, when we are talking about the security of a system, it's important also to take into account the context where this device is going to be used. So the same device can be applied on different contexts, and that's important to take also into account the context when we are identifying and we are trying to verify the security and privacy capabilities of a system. Please go to the next. So in this case in COBALT, but also I would say in combination or in collaboration, I would say with other projects like Medina previously, Emerald, DOS in this moment, we already have tried to, in some sense, try to identify if it is possible to look for a kind of more machine-readable format that facilitate the share of the information that I already mentioned that is needed on the different phases of the life cycle, of the different components that constitute the system, and related to the different elements that are needed to take into account when we are talking about the certification. And for that, we have put our eyes on an effort that is already been started in the NIST, that is the OSCAL. OSCAL is an effort that already has been launched and that in Europe has already started to have some kind of impact, also with some collaboration that we have started with ESCO, but also with, for example, we have already meeting also with NISA in order to understand if they can be used in the context of the certification process. And the good thing in that sense, or the advantage, I would say more than the good thing of OSCAL, is that at least OSCAL, what it's providing is a baseline, in some sense, of a structural way to document and provide different kind of document associated to the security information of a system. Here you can see several of these documents that are being aggregated in some way on different, what they call it, layer. in some sense that represent different aspects of the security analysis and evaluation of a system. So, for example, you can see that there is a list of different documents that are associated to how to do the evaluation of the security of a system, which are the results that already have been obtained, for example, through the assessment of this security evaluation, what action are needed to be planned, basically in order to impact over the results of this security evaluation. Another block is more about to describe the system. What are the controls that already are being implemented in that sense? And for example, another one is more related to the existing catalog. What are the baseline that we can use in order to do the evaluation process in some sense? So go in that direction, please go to the next. What we already have tried to do, and we are doing it already in the context of COBALT, is to first take as a baseline this idea of OSCAL. You will see later that we are extending, basically because we understand there's other aspects, specifically when we are talking about the life cycle that need to be taken into account, that can be also added, I would say, to the functionality of OSCAL. But in general, our vision here is that starting from this OSCAL meta schemas, basically, we have created what already was presented by Ioannis, is about our CCM. No, it's our a model for doing the certificate conformance that basically at the end is able to reuse part of the document that already are being provided by OSCAL, as already mentioned, extending it in order to integrate, for example, information like, as you can see here, when we are talking about the system, the different H-bomb, the S-bomb, the extended map, also in order to link it to the behavioral of the system, the threat mood, the bugs, vulnerabilities, etc. That all of this information can be integrated on the description, so that at the end we connect it with the idea of the certificates and the evidence that are needed in order to verify the behavior of the system, and finally can be easily be used to be updated as already mentioned, in the kind of dynamic environment where basically we understand that future evaluation will need to carry out, they need to update, they need to improve, or they need to change certain of the information that already has been aggregated on this kind of document. The important thing here that in our vision is that in that way, as you can see here, we can offer different views of the information that is needed for the different stakeholders, depending on their real interest or their real focus on the evaluation of and the analysis of the security, all the vulnerabilities, or the certification process associated to a certain system using this kind of a structural document that we are presenting. So if you can go to the next. Basically, at the end, here we will show you, I mean, very quickly, if you want to have more detail, please, you can go to our website, and on some of our deliverables already explain this quite in detail. But basically what we have tried is to identify, as I said, what part of the OSCAL can be used for different, I would say, components on our system. Now, for example, here you can see that starting from the OSCAL component definition model, that facilitates this machine readable format. In our case, we have enriched it with the link to the description of different sources that you can see here, where we extend the information associated to a certain component. Here you can see an example of a certain component definition. In this case, it's a concrete system that is a Mongo database, and we link it with the basic description that is as can be associated on the OSCAL component with the list of different subsystems or subcomponents that provide information, as you can see here, with the COBALT bomb enrichment, with the different information associated to the links to the document that are associated additional information that describe the characteristic, the property, the security, vulnerability, for example, that are linked to this kind of device. That gives us, as I said, a complete expanded, I would say, mapping of the information that is being required by the different components, stakeholders already mentioned, that will use later this kind of a document for their usage on their different component functions and tools. If you go to the next one. Another issue that we already extend in some sense, that this is something that was not existing. It's not existing actually in OSCAL, but we are extending during the context of the COBALT, is what we call the certification scheme ontology. So basically, in order to later provide for a certain component a certification process to create the corresponding compliance and evidence collection, we need to associate with what we call a certification scheme ontology, where we link, as you can see here, different components that at the end also are connecting to some of the document that already had been used in the OSCAL definition of that component in that sense. Here you can see some example where we can see the compliance metric, the certificate standard that are going to be used, the boundary conditions, the risk catalog that at the end also is connected to the compliance metric, and how these metrics associate with certain controls that will be used in order to be connected, as you can see at the end, with the corresponding policies or normative that need to be used in order to apply to this control in that sense. So you go to the next one. This allows us to create, as you can see here, a connection in the integration of OSCAL within this COBALT certification scheme, because at the end, as you can see here, from the certification scheme that we already have defined, so we connect with the different elements of the OSCAL. For example, specifically, if we're talking about the device, we are talking about a certain profile. The profile is also based on the catalog, that is the collection of basic information that we have about the different device or systems that we are using to do the certification in that sense. So in that way, we create a cross-reference between all the different elements that are part of the, I would say, the structural meta schema that we are using linked to the different services that later you will see we are implementing as part of the COBALT. So you go to the next. At the end, as you can see here, in a general way, so we have we can go from the definition of the security requirements. From there, we go to the COBALT compliance metrics, and the different COBALT metrics then instantiate to the different specifications that are needed associated to that. The good thing here is that when we do that and we create these connections and the linkage over the different document, over the different instance of the document, we are able to avoid the duplicate of certain assessment, so we can use the same evidence for the multiple standards compliance, and they are all connected to the same, I would say, the component that is being evaluated in the context of the COBALT framework. So we go to the next slide. And finally, as already said, we also create a COBALT certification ontology linked to all this process. So basically, we go from, as I said, from the system, the different component. From the component, we have the compliance criteria. Then we use the evidence collection, and now after that, we are able to create a process to assign a certificate that is also, again, not part of the COBALT. It's an extension that also we are considering our part, that at the end we are able to associate to the whole process in order to identify who is doing the certification process, who is the applicant organization, which is the target of evaluation, again connected to the schema that I already presented, the scope of the context, so the scope of the certification, and other information that we are able to link with the final structure that we are generating. So if you go to the next slide, at the end, and this is my last slide, basically what we already have identified as part of COBALT is to create this common certification model, the CCM, that basically is providing a machine-readable, I would say, meta schema that is able to support, as you can see here, provide information from different, I would say, sources that are required for doing the certification, but also that is able to support the different phase of the certification process that go from the first identification of the target of evaluation, the specification linked to that target of evaluation of a collection of security specification metrics, the providing then of a evidence collection in order to provide an assessment result and provide a dynamic risk assessment, and as a consequence of that, being able to understand the status of the security, security evaluation of the system, and based on this, take a decision on the what is still needed, if these new mitigation strategies are needed or not, and finally to manage the process of the certification in order to provide a continuation, to renew, update, or whatever it is necessary as a consequence of this process. As you can see here, in all these phases, the different part basically of our CCM, as already mentioned, is based on the extension of the OSCAL that, here we call it Euro-OSCAL, that is also an initiative that was started by Medina some time ago, are able to provide the necessary information, like as we mentioned, the information like the mood, the MOMS, or etc., the certification schema, the mitigation or the threats associated to the process in order to do the evaluation, and finally to create a certification status, a certificate and a certification status associated to that one. And all of them are facilitating, as you can see, that different stakeholders can be able to use this information with their own views, but at the end, facilitating that there's no duplication, a common access, and basically using the CCM as a lingua franca, if you want, between the different tools and facilitate the interoperability in the future. And that's all for my side. Thanks.
Thank you. Thank you very much, Antonio. This presentation clearly shows how automation and machine reliable standards can support more efficient compliance processes. Next, we will explore how modular frameworks can support cybersecurity implementation. I'm pleased to invite Evangelos Michos to present the CyberSynchrony platform as the technical manager of the project and the modular cybersecurity framework as a whole. Evangelos, the floor is yours.
Yes, thank you, Eleni. Basically, my presentation will be on explaining on a high level the technical aspects of CyberSynchrony, the other project. So basically, I would explain that CyberSynchrony is a modular cybersecurity ecosystem that can assist SOC analysts and cybersecurity experts towards real-time threat detection, automated incident response, and cross-border collaboration. The problem we're facing is the fact that out there, all of the cybersecurity organizations have fragmented and isolated cybersecurity solutions. So in the end, the tools do not communicate effectively one with the other. And our ecosystem is integrating monitoring tools, threat intelligence capabilities, risk analysis tools, training modules into a cohesive architecture where everything is integrated. Each capability is implemented under a specific modules. Some of these were presented by Violeta, our coordinator, a few slides back. And actually we're mapping the core functionalities of our project under 6 discrete modules. In the end, we're addressing the operational and regulatory needs of public administrations, healthcare institutions, and academic entities, which is a subset of the NIS2 directive. Next slide, please. So talking about NIS2, we have 3 pilot use case leaders in our project. We have digital healthcare, public administrations, and academic research. Some of the common threats identified in the NIS2 domains were ransomware attacks, phishing, insider threats, DDoS attack, and credential theft and supply chain compromises. So some of the risks emerging from these are IoT vulnerabilities and software and hardware supply chains attack. So our idea, the core idea of the project, is to strengthen cyber resilience in these critical entities and support the critical entities with real-time security solutions. And our strategy is that we're currently designing sector-specific test scenarios for the use cases, and we're promoting this modular ecosystem across member states. Next slide, please. I would explain the main concept as is. We're starting with basically the end user of the platform, the one that logs in the platform. We have either a SOC analyst, or it could be an IT security team, or it could be a cybersecurity officer that logs in the platform. The initial UI, which is let's say the green rectangle, is basically the access to all modules, insights, and recommendations. This is basically the high level of our platform, and this communicates with logs and analytics tools that are installed locally in all of these NIS2 organizations. We have data collection agents, and we have specific tools that assist us towards network and threat detection. And this data is validated through a blockchain ledger and communicated to the cloud deployment, where the UI and the insights are offered to the platform users. At the same time, our project has also standalone components that are, as the word says, they are deployed in each of the partners' own premises, but some of them require log or CTI data, so they need to communicate with our platform. But others, like for example, we have tools that conduct phishing campaigns, are standalone tools and operate by definition individually. Next slide, please. So the way that we are deploying all of this solution is that we're proposing a hybrid architecture, and we have two clusters. We have an on-premise cluster, which is basically, you can imagine that through a terminal, we are getting network and alert data, and this is communicated to the cloud deployment. And the core essence of the project is actually the fact that the final actions are intended to remain under human control. So we want, of course, to avoid issues of incorrect misclassifications. So we give ultimately our recommendations. We're giving the choice to the human to make the ultimate decision. We have a cloud Kubernetes cluster deployed on the cloud that conducts the heavy operational processes and offers all the visualizations and insights. For example, when we talk about visualizations, we're talking about data about anomaly detection on the network traffic, data about threat intelligence and IOCs, recommendations to the SOC analyst, the data received to the server, and all of these visualizations are under a central point. At the same time, the on-premise configurations, which is basically the on-premise configuration in a hospital or to a research organization, are basically tools that collect, analyze, and aggregate information, log and network data, and are communicated. They are communicated to the cloud deployment through blockchain. Next slide, please. Some of the key technologies are that we have tools that assist us towards performing network threat detections. We have Suricata to assist us on this. This is one of the two tools that are installed in all of the pilot deployments and offer deep packet inspection and intrusion detection network data, depending on the packets we're receiving. At the same time, we have anomaly detection tools that can apply machine learning techniques to detect abnormal behavior patterns in this network data that Suricata communicates. Next slide, please. We have also tools that assist us in threat world intelligence. We have MISP that is deployed in the cloud and can correlate all of the information that we are receiving from the on-premise in order to detect emerging threats. We have a blockchain integrity ledger, and we need it in order to have immutable data. We want to make it sure that we have tamper-proof data, and nobody can act as a man in the middle and mess with our information. So we need this for traceability and transparency. We have components that perform identity and access control. All of these components communicate through this tool in order to validate ourselves and validate where we have access and where we do not in the platform. Next slide, please. We also have tools that perform risk assessment and exposure analysis. One of the most important of them can identify exposed infrastructures, misconfigurations, and anomalies in order for the organizations themselves to improve their cybersecurity exposure. You have, as I said before, tools that conduct phishing campaigns in order to, of course, raise awareness in a company, and a and tools about gamified training and cyber hygiene that offer an interactive UI so that we can educate users on common cyber threats and best practices through a more intuitive UI. Next slide, please. As I said before, we have a modular architecture. The users log in the platform UI where all of the information stands. We have the identity manager, the key clock that handles all the authentication between the components and the users. And next, you see that we are mapping all of the tools we have per module, or we can say differently, per feature. For example, one feature could be somebody wanting to perform risk analysis and threat intelligence. Another one would be about cybersecurity, compliance, policy toolkits and training. Another one could be about real-time monitoring detection. So you have 6 core modules, and all of the tools are grouped into the specific modules, and the users select the module. And as I said before, the data is validated through blockchain and through information received from data collection agents in the NIS2 sectors. Next slide. This is actually a very brief UI of the starting page of the platform. As I said, the project offers modules that each perform specific activities. Others, like CyberWise, are related to awareness and training. Others, like CyberGo Plus, relate to governance and compliance. Others are for cross-border sharing, threat intelligence and risk analysis, incident response, and monitoring and rapid response. So the user clicks on the module, and all of the functionalities that belong to this module are offered through an integrated ecosystem from behind the scenes. Next slide. A very short overview of all of our components. In total, we have 18 components in our architecture. And as you will begin, scrapping through this information, you will see that each of them does a specific features. Others, like MISP, collect, correlate, and distribute IOCs to detect emerging threats. Others, like Wazoo and Suricata, perform log analysis in the NIS2 infrastructures and help us with alerts, logs, and traffic inspection. Others, like, for example, TrustSense, help us towards having a more efficient government procedure in the organizations. We have the blockchain in order to perform integrity and immutability in our artifacts and how the information flows in our ecosystem. We have the anomaly detector that tracks the network packets. We have the response playbooks, which actually is the endpoint. It's the last step in all of our flow. And this integrates all the information from all of the tools and basically provides the recommendations to either the SOC analyst or the cybersecurity team that based on the information we have, we are suggesting these actions. Of course, tools for gamified cybersecurity training, real-time monitoring, cyber attack simulations, red-blue team evaluations, and a large variety of tools under an ecosystem. Next slide. Ultimately, cybersynchrony is not to be treated as a set of isolated tools. We are bringing together detection, threat intelligence, response, risk assessment, training, and secure data exchange. We envision it as a one-stop platform for somebody to perform detection, intelligence, response, assessment, and training. The hybrid deployment Kubernetes environment can assist modular deployment across all of the pilot sites, and the fact that we have grouped the on-premise tools under one Kubernetes clusters means that we can very easily deploy through Docker our data collection agents in all of the pilot infrastructures, and in the end, public administrations, healthcare institutions, and academic entities using the CyberSynchrony platform will be able to better adopt cybersecurity capabilities in a more modular and flexible way than before. And I think that this is my last slide.
Thank you, Vangeli. This approach highlights how flexibility and modularity can help organizations better align with cybersecurity requirements and policies. We will now move on to our last presentation, which is the COBALT certification platform. But before going to Sarah for her insights, I would kindly ask all the participants if they have any questions or any remarks or any suggestions for the policies. Please feel free to submit your questions at the Q&A session. We have already, I've seen we have 2. So yes, please engage with this session. Thank you. So I would like to invite Sarah to present the COBALT certification platform as a tool to support automated certification processes. Sarah, the floor is yours.
Yes, before starting, Eleni, are you sharing PDF or PowerPoint?
It's a PowerPoint. Do you have a specific requirement?
Yes, because I have some animation, so just to know.
Okay, so yes, you'll have them there.
Okay.
Thanks.
Okay, perfect. Thank you so much. Okay, so now that you already have the notion of what is COBALT about and one of the most important part of this project, which is the CCM, the idea is now see how things are going to work together, all the pieces and the components. So I want to start with the picture, with the last picture that Antonio shared in his presentation, to explain that at a high level, COBALT organizes the certification process into 3 main workflows. And these workflows mainly capture the typical steps that you will find in cybersecurity schemes. Indeed, we have the inspiration from the Cybersecurity Act and the EU CS. So first, we have a setup workflow. When we define the target of evaluation, certification requirements, we deploy all the pieces that we need to start the certification process. Then we have the assessment workflow, when we can find activities to collect the evidences and to perform the risk assessment. And the objective here is to check the compliance of the target of evaluation. And finally, we have the continuous certificate management workflow, where based on all the information that we have collected before, we take decision on the certificate. If everything is okay, we decide to renew the certificate, but if something is wrong, we will need to do some actions. So in brief, in COBALT, we start from the target of evaluation definition, and we end with a decision on the certificate. And the glue of all of this is the CCM that Antonio already explained before. So next slide. Okay, so the workflows in COBALT are supported by different components that are organized in this architecture that you can see here. We follow a layered architecture where each layer is responsible for a different part of the certification process. So on the top, we have the operations layer that includes the real system, the target of evaluation, and its security digital twin, the SDT. The SDT is just a virtual representation of the system that mirrors the security state of this real system. So the certification activities are performed directly on the security digital twin. So we don't affect the functioning of the real system. This is not shown here because this is a simplified view of the architecture, but the real system and the security digital twin are synchronized using this IDS connector that Giannis mentioned at the beginning. So then we have the assessment layer that aggregates all the components responsible to collect the evidences, to perform the risk assessment, the conformity assessment. And together, all these tools assess the security of the TOE and identify potential risk. All the information that they generate is later forwarded to the next layer, which is the management and orchestration. In this layer, the orchestrator gathers and forwards all the information, and the decision engine uses this information to decide what happens with the certificate. And we also have some additional components here. For example, the security digital twin manager that handles the digital twin, or the CCM manager, which is one of the most important components here in the COBALT architecture because it manages all the information that is related with the certification process using this CCM that was presented before. And finally, in the bottom, we have the CCM ledgers, where all the data related with the certification process is stored in a secure way. And here we leverage on Hyperledger technology to support different ledgers for the different stakeholders. In particular, we consider 3 ledgers, one for the manufacturer, intended to store information about the SBOMs or MUD files, another one for the certification authority to store information about certificates or assessments, and another one for the domain operators to store information about the evidences that are collected during the runtime or new threats or mitigations. Okay, so let's go back to the workflows and let's see how all these components actually work together in the practice. So next slide, please. Let's start with the setup phase, where we describe this target of evaluation and we prepare everything to begin the certification process. Okay, so first we assume that a certification authority, a CAP, using the COBALT graphical user interface, has defined a certification scheme, basically selecting the relevant metrics, the target values, and the requirements. And this scheme is stored in the COBALT framework to be selected later for compliance. Okay, so then when a manufacturer or operator, you should advance a bit. Eleni? Okay. So when a manufacturer or an operator wants to evaluate the conformity, he can select which certification schema wants to use. This is mainly used through the COBALT graphical user interface, and he uploads all the basic information about the target of evaluation. For example, the SBOMs, the mood, metadata or evidence from previous assessment, and so on. And after that, the target of evaluation is registered in COBALT, and all this information is stored in the CCM manager using the CCM model. So it's the red part. If needed, the CCM manager can also obtain the information from external servers. For example, if instead of providing directly the file, a URL was provided. And the CCM manager also checks the integrity of the information based on the hash that is stored in the ledgers. Based on all this information, the framework creates the digital twin, which is the step 5. And once the digital twin is created, all the necessary evidence collector and the assessment components that are needed to for assessment the selected certification scheme are deployed. And finally, in the last step, another one. In the next step, the digital twin is synchronized with the real system, enabling this continuous data collection. So at this point, the system is fully integrated with into the COBALT framework, and everything is ready for the certification. Okay, all of this can seem a bit complex, but from the user perspective, everything is accessed through a single interface through the CCM manager. And here you have a screenshot of the graphical user interface when you can see the COBALT homepage. From this page, we can access to all the submenus to register a certification scheme, to register a target of evaluation, to see the status of the risk assessment, the status of the certificate, on the information. And then in the next slide, you can see the page for registering and listing the certification schemes and profile, which was the first step that I mentioned in the flow. Okay, the second workflow in COBALT is the point-in-time assessment, which evaluates the system as at a specific moment. Okay, so at this point, the evidence collector starts to extract and process all the evidence from the security digital twin, which, remember, is synchronized with the real system. All this evidence may include, for example, configuration or runtime information, logs, network traffic, and any kind of information that could be relevant for the metrics and for the requirements that we have selected in the certification scheme. Inside, we also have components to detect attacks in the security digital twin, and in this case, stop the certification process. All this evidence is later stored to be used. Next, the system performs the conformity assessment, which is all this step 3, evaluating the collected evidence against the certification scheme, based on these metrics and all the target values and evidence. Next step. Okay, so if a non-compliance is detected, we trigger a risk assessment process, which evaluates the impact of the issue that has been detected, considering the previous assessment and also the current assessment, so current and previous. And finally, all the results are sent to the decision engine to take a decision on the certificate status. The third workflow in COBALT is the continuous certificate management, which is responsible for monitoring and updating the certificate status. So based on the risk calculated before, the decision engine gives a recommendation about the certificate status and forwards this recommendation to the manufacturer. If the target of evaluation fulfills all the conditions and everything is fine, the certificate can continue being valid. In this case, we don't take any action. The system is certified and we can execute new assessments continuously. However, if the risk is not acceptable, the certificate may be updated. Potentially, we withdraw or we suspend the certificate. In this case, the CCM manager updates the certificate status in the ledger, and the manufacturer is required to take some actions. In the meantime, next step, the security digital twin is stopped. And once all the necessary actions are complete by the manufacturer can request a recertification to update the certificate status. Okay, from the user perspective, all the results of the assessment are presented in the COBALT graphical user interface. And in this case, you can see that the target was to obtain an 80%, and the target of evaluation obtained less than 40%. So the risk is not acceptable, and some mitigation are required to keep this certificate valid. And finally, here you have also a screenshot in which the user can have an overview of all the certificates and the registered target of evaluations. So to check all the details and also to have the possibility of obtain the PDF. And I think, next slide. Oh, yes. I think that's all I wanted to say about the COBALT framework. Thank you so much.
Thank you so much. And all the speakers for their insightful presentations. We have seen how both projects address cybersecurity from complementary angles, let's say. Now we are able to move to the final part of this webinar, which is the Q&A and discussion on policy recommendations. In this session, we would like to go beyond clarification questions and really focus on your perspectives, especially on policy gaps, certification challenges, and opportunities for automation and cybersecurity compliance. So we encourage everyone to use the chat to ask a comment, propose any policy recommendations. So we welcome both questions and short reflections so we can enable the policy recommendation discussion. I will start with the first question in the Q&A session, where from Frini. From your perspective, how could a platform like CyberSynchrony make it easier for organizations to comply with cybersecurity policies and certification schemes? So is CyberSynchrony enables this policy alignment, and how? Maybe Violetta, I can pass this question to you.
Yes, thank you. I can start. So from a pragmatic and the system level perspective, I would say the real problem with cybersecurity compliance today is not the lack of rules, but the fragmentation. the interpretation overhead, and the operational disconnect between the policy and the execution. So from our perspective, a platform like CyberSynchrony can become valuable precisely if it collapses that gap. So, for example, mapping regulatory requirements directly to technical and operational controls as well, providing pre-configured control libraries. That could be also something that could further be exploited through the platform, and automatically link controls to systems, data flows, and responsible teams. So I would say the platform, basically one of the modules could support into that area, because this is where we see mainly the gap right now. I don't know if maybe Evangelos from Janus would like also to mention something in regards to that. But...
Yeah, from my point, I fully agree. Of course, we have some other personnel from our group that currently is leading the pilot toolkits in the project. So to be perfectly honest, I'm not the best person on this to answer. But regarding the modularity in the ecosystem and how everything is aligned, I think that we have something pretty nice to our hands. But sorry, I'm not an expert in this policy, so I cannot contribute any further. But of course, I would like to remind everyone that regarding when we talk, I'm not gonna talk about policies. I'm gonna talk about recommendations. We had some physical workshops in the project, and we had discussions on whether we feel that the project should act on an automated scope, which means that basically you get all the alerts, you get all the data. Do you have the project act individually and, for example, shut down a port or kick out a malicious IP, or you give the option to the actual user of the platform? And we decided that it was best to still keep the human effort in there, just provide the recommendations to the SOC analyst or the security team, and let them act on it. And it was a collaborative effort.
Great. Thank you both. Thank you, Violetta. Thank you, Vangela, for your insights on that. Let's move on to the second question, which is, if you could recommend one concrete policy change to EU level to improve cybersecurity certification or compliance, what would it be? Maybe Anjan, this question can be further answered by you. So if you could recommend just one concrete policy change, what that would be?
Yeah, thank you, Eleni. Yeah, this is a very common question, and I would say a common proposal could be making sure like the requirements for cybersecurity starting from the design level of the product. That is, if we're talking about the complete supply chain, then it's better to start from the design phase rather than putting the requirements in a middle stage of the product. Like in our daily business, we have seen this. If the requirements are not put forward from the beginning, then it's a problem. Like you have to, there is a feedback loop. Like you have to go through to the beginning to change the design and then build the product. For example, if we talk about some regulations, like for example, if we talk about CE marking, like if a product is already built and like it's not designed according to the requirements, you have to change like the whole product and go back to the design phase. So the same applies for all cybersecurity certification requirements, I would say. And the second thing is, so it's just one, but I would also like to mention another point is that navigating through these policies is a difficult thing, and I think for SMEs, like if we talk about SMEs, it's a very complex thing, and also affordability for SMEs to services to hire big organizations to navigate through the policies is a challenge. And with the regulations coming up, for example, CRAs, mandatory regulations that are coming up, I think what we are doing in COBALT, for example, or also CyberSynchrony, like these kind of initiatives would make sure like we have a digital platform and we have automated guidance through the schemes and the policies that we put forward. So yeah, that's what I can comment on.
Great, great, thank you. One question I have myself as a third party, let's say that I'm not involved in the project and I have no idea about COBALT. We have seen in the most of the presentations speaking about certifications and the constant need to update the certifications. So in a practical aspect, a user of the platform, of COBALT platform, if they have a certificate and it's accepted, but they want to update that certificate, how this is possible? Can you give insights on that so people can understand better the usage of the platform? I might give this question to Antonio Scometa.
Yeah. Thanks for the question. Yeah, I mean, I think that the question here is that why we need first a recertification. I would say that is the first thing. and the issue is that I think what we already have commented during the different presentation is that certification is not a static issue. So basically, when you do a certification of a product, of a service, or a device, if you like to, that certification means the evaluation of the security or the privacy aspect of that device or that system on that moment, in that sense. So basically on the actual design, actual vulnerabilities being identified based on the actual information, if you like, or recommendation that already exists, regulation, and so on. But the things change quite frequently, I would say, in some sense. So new, specifically on now in the scenario, that new threats appear, new vulnerability appear, either from the manufacturer can detect maybe a possible, I would say, failure on their own design and so on. So you will need, in any of the case, a continuous recertification of the product because of any of this reason, no? Because a new threat is being identified, a new vulnerability, a new aspect or update that is being provided to the device. So that's why it's important that we maintain, basically, first of all, the information that we have from the beginning. So in the sense of, okay, what happened at the beginning of why was that certification, and what were the evidence that were used to demonstrate the certification of that system, so that in the next step, we can check what has been the change and the reason why this new certification is being required. And based on this, try to identify, I would say, do a new risk evaluation of the change being introduced and how this affect basically the previous status that we have of the certificate in that sense. And that is basically all why we mentioned this about the life cycle management of all the process, because at the end it needs to be something quite dynamic. It needs to be ready to be adapted in the case of a new situation, and then basically you need to relaunch the process, check what already has been improved, reevaluate, and based on this, take a new decision about what is the certificate of that device or that system. If it is still valid, if it is maybe valid with a certain modification or mitigation that need to be provided by the manufacturer, or it need to be withdrawn because basically, I mean, it is not compliant with the actual regulation that in this moment are in application to the system. No? And the important, as we mentioned, is that all this process that we are talking about, I mean, having all the information, what happened, what has been, what are the evidence that's being collected, what are the regulation being applied, etc. All this information should be, I would say, attached in some sense to the story, if you like, of the device and the certification process, so you can continually analyze and use it in order to maintain the status or renew the status of the device or the system in that sense.
Nice, Antonio, thank you. Is it easier to do the recertification, or is the exact same process in the platform of COBALT?
Well, in our case, basically the idea is it should be the same scenario that the initial certification. So there's no big difference between a first certification and a recertification. I would say in some sense. At the end, it's basically again the same process. It's basically just in the case of the recertification, you will use basically, as already mentioned, the previous information that already has been gathered regarding the system, the target of evaluation, and you will reuse it and update it. That's why it's important. The vision of this CCM, because at the end CCM provide the structure, the meta schemas basically that allow you to use information coming from what you already have generated plus new information that you need to add or need to link, because in some cases not just to add the information but just to create the adequate link to the information. So at the end you maintain the storyline basically of what has happened with the device. So from our perspective, it's similar to a new certification and a recertification is basically quite similar and from the point of view of the tool.
Great, thank you. I don't see any other questions in the chat, but please, if you're coming from an SME or in industry or a certification body, standardization body, your insights are really, really valuable. So please go ahead and share with us what you're thinking, even if it's something basic or small. We welcome any insight. Just a question to Ioannis from Demokritos. Do you see any changes in the upcoming years in regards to certification? Do you believe the landscape will change? And how do you see this certification framework landscape being modified in the next 5-10 years?
That's a very good question, Eleni. First of all, I would like to state that it's actually these changes with the needs that each organization has, and currently this also is being quite affected by the use of other technologies that are being integrated into the operational processes. And for example, this is AI in this case, and the use of large language models, for example, to automate some works. And the thing is that currently the whole, let's say, technological landscape is quite unstable. So in my opinion, I think that there will be quite many changes because we have not yet established what are our needs, how the usage of most of these tools is going to be handled, and what will be the restrictions that come from the EU level. So all of this will need to be eventually integrated within a certification framework. So we could also, let's say, ensure that the operations that take place within each organization are being conducted within, let's say, a safe, within a safe context.
Nice, and this gives a good patch to the next question to Sarah. Sarah, do you believe that COBALT platform, the way that it's structured, can adjust to these upcoming changes in the certification landscape, or it doesn't have this flexibility to get upgraded in the future, even after the completion of the project, if exploitation will take place of the platform?
Yeah, I mean, in the architecture, indeed, it's quite extensible. I haven't shown because I show in the slide a simplified view of the architecture, but we also have some generic evidence collectors that could be extended maybe to support any other kind of technology, and maybe integrating also artificial intelligence and so on. And I mean, it's a collection of components that could be extended if required and adapted to the future technologies. So I don't think it's a closed framework that will be fixed over the time.
That's great. Flexibility is always a good thing, especially when you design platforms and with the constant changes within the landscapes, even the cybersecurity or the certification landscape, which is rapidly changing. Flexibility gives you some more opportunities to exploit the tools. So As I see, there are no more discussion points. We can approach to the end of this session. I'm going to share with you some final remarks of this webinar. It was obvious the need for more practical and scalable certification approaches, the importance of supporting automation and continuous compliance, and the value of flexible modular frameworks to enable cybersecurity enhancement, alignment with policies, and training material tailored to these schemas. So thank you all very, very much for this engaging discussion. The key highlights of this day are these remarks, and all these insights are extremely valuable and will directly feed into the policy recommendations of both COBALT and CyberSynchrony projects. So thank you again to all the speakers and participants for joining us today. Visit our websites, engage with the projects COBALT and CyberSynchrony, subscribe to the newsletters, and get informed about our latest news and events. We will having some more webinars and training sessions coming on. So please find us online and engage with the projects if you feel that it's something relevant to your work. Have a great day, and thank you so much.
Thank you, Eleni. Have a good day too.
Thank you, everyone. Thank you, Eleni.
Thank you so much.